You ever stop and think about how much of life is just doing the same thing over and over again? Seriously, from your morning coffee routine to, well, anything you practice, we repeat things constantly. And it turns out teaching a computer how to repeat itself is maybe one of the most powerful things you can do in programming. So let's get into it. Let's talk about iterations.
Okay, I know. I know this sounds like the setup to a really weird joke, but stick with me, because I promise there's a real connection here. And the answer to this question, it gets right to the core of how computers, well, think. Just keep that in the back of your mind for a few minutes.
Right. So before we even think about writing a single line of code, we got to get one thing straight. You are already an expert in repetition. Our lives are basically built on these repeating patterns or loops, whether we actually call them that or not.
Just think about something super simple, like slicing a carrot. First, you do a little prep, right? You grab your gear, then you get into a rhythm, a cycle. Put the carrot down, lift the knife, and slice. Then you do a quick check, am I done yet? If not, you do it all over again. That part right there, steps 2, 3, and 4, that is a loop in the real world.
So the big question is, how do we take that very simple, very human logic of slicing a carrot and translate it into a language a computer can actually understand? Well, this is where it starts to get really cool. Let's see how that happens. In the world of programming, we call this process an iteration, or way more commonly, just a loop. Now, look at this. A loop has 3 main parts. You've got the preparation to get started, the actual tasks you want to repeat, and, this is key, a condition that tells the computer when to stop. Does that sound a little familiar? And boom, here's where it all connects. The preparation, that's just getting your board and knife. The tasks, placing, lifting, slicing. And the condition to stop, well, it's that super important safety check. If you see only your finger, quit. That is the exact same logic that runs a computer program. See, you already get the structure of a loop intuitively.
Okay, so now we know what a loop is, let's talk about the actual tools programmers have to build them. There are basically 2 main flavors, and each one is perfect for a different kind of job. So on one side, you've got the for loop. This is your best friend when you know exactly how many times you need to repeat something. Like, hey computer, slice this carrot exactly 10 times. Easy. But on the other side, you've got the while loop. This is for when you don't know how many times you'll need to repeat. You just want the computer to keep doing something while a condition is still true, like keep stirring this sauce until it sticks.
Digging into the for loop a bit more, it really loves working with a known list of things, or a set range of numbers. And to keep track of where it is, programmers use a counter variable. You'll almost always see this called I, which is just short for index or iteration. Think of it like you're just ticking items off a checklist, one by one. Now, the while loop, it's a bit more free-spirited. It always checks its condition before it even starts an iteration. And get this, if that condition is false from the very beginning, the loop might not run even once. This makes it absolutely perfect for things like waiting for a user to type in the right password. The program has no idea if it'll take 1 try or 20. It just has to keep looping while the password is. Now, loops are incredibly powerful, but you don't just, launch them and pray they work out. As a programmer, you need to have precise control, especially for handling weird or unexpected things that might happen inside that repetition. And for that, we have the break statement. This is literally your big red emergency stop button. Remember our carrot condition? If you see only your finger, quit? Yep. In code, that is a break. It tells the computer, stop what you're doing, get out of this loop right now, I don't care how many repetitions are left. And then you have its cousin, the continue statement. This isn't a full stop, it's more like a skip a button. Imagine you're slicing that carrot and you hit a weird mushy spot. You don't want to stop slicing altogether, right? You just want to skip that one bad slice. Continue tells the loop, hey, just forget the rest of the tasks for this specific round and jump straight to the start of the next one. Okay, so we've gone through the theory, we've talked about the tools, but why does any of this really matter? Let's zoom out and see how these simple little loops are the engine behind the complex stuff we use every single day. As one programmer wisely said, the loop isn't just a feature, it's a foundational block of all programming. Honestly, trying to build any serious software without loops would be like trying to build a house without a single nail or screw. It's just not going to happen. To really see this, let's build a super simple countdown timer. Imagine telling the computer, for every number from 3 down to 1, I want you to print that number to the screen. So the loop kicks off its very first cycle, and it starts with the number 3.
After it prints the number, we'll tell it to just wait for 1 second. Then, because the loop's condition isn't met yet, it automatically repeats the whole process for the next number in line. So now it prints 2 and hangs on for another second.
And finally, it gets to the last number in its range, which is 1. It prints it, it pauses, and then it checks its condition again. The countdown's finished, so the loop is officially over. That entire sequence, that was just a simple for loop doing its thing.
And you can see how that simple idea just scales up to power all sorts of complex features. Loops are used for input validation, making a website ask you over and over again until you finally type in a valid email. And for anyone out there learning to code, you'll find that pretty much every single problem on competitive coding sites like Caddis needs a clever loop to solve it.
So there you have it. From something as mundane as slicing a carrot to building sophisticated software, the loop is the engine of repetition that makes it all possible. It's such a simple idea, but with truly powerful applications. So the only real question left is, what are you going to build first?